Thank you for joining me for the third problem of the level 2 torque calculation problem set. This is question number 6. It asks us to calculate the torque on the lever. So as you've seen now, with all of the other level 2 problems we've done, we've had to engage with a force that's not perpendicular to the direction of the lever. So we've had to modify or be a little more adaptive. Instead of doing torque equals the perpendicular force, which we're not provided, times the distance between the pivot point and where the force is being applied, we're going to have to use force times distance equals sine of theta. And theta is the angle between the force vector and the direction of the lever. So let's see what they gave us. We have a force that's provided that's equal to 60 newtons. We have a distance vector, position vector actually, for distance, which is 2 meters. And we have a theta that's equal to 45 degrees. And if we want, at this point, we could actually already calculate what that sine of that 45 degrees is. So when we input it in our input it into our equation. So I'm going to hit 45, and then I'm going to hit the sine button, which I have to turn my iPhone sideways for, and I get 0.707. And what that pretty much means is that if I look at the vertical component of this force vector, this distance here is approximately 70% of whatever the distance is here for the hypotenuse. And so if the hypotenuse was 1, then this one would be 0.707 times whatever the hypotenuse is, and so that would be this guy here. Anyways, so now we're ready to plug and chug into our equation. So we have our force vector, which is 60 newtons, times the distance, which is 2 meters, times sine theta, which we said was 0.707, 0.707. Always got to put those zeros in front of the decimal. If you have a very small number, sometimes it's very easy to forget. And what we end up getting is I have 120 Newton meters times this 0.707. Because remember, I'm only going to get 70% approximately of that. So 120 times 0.707, I get 84.84 Newton meters. And the last thing I need to do is determine the sign of this torque, which is indicating the direction. And according to this, this force vector is going up and out to the right. And if it was going to the right, this actually would be what that vector would be. It's going to be turning it in the clockwise direction, which is negative. All right, thank you very much.